Welcome to our deep dive into the evolution of computers, from enormous room-sized machines to the brink of quantum computing. Let's travel through time as we explore the 5 generations of computers, their revolutionary technologies, and key milestones that have shaped our digital world. Our journey begins in the 1940s with the first generation of computers. These giants used vacuum tubes as their main electronic components. They were huge, generated a lot of heat and consumed copious amounts of power. Examples like the ENIAC, UNIVAC, IBM 701 and IBM 650 were designed using basic machine language. Programming was laborious and the machines occupied entire rooms. Next, from 1956 to 1963, we enter the second generation. Here, the bulky vacuum tubes were replaced by the smaller, more reliable transistors. This leap reduced heat generation and energy consumption, making the computers faster and more dependable. The size of these systems shrank and paved the way for easier programming with early high-level languages on the horizon. The third generation of computers, spanning from 1964 to 1971, introduced integrated circuits, bringing hundreds of transistors onto a single chip. This innovation shrunk computers further while enhancing speed, reliability, and precision. It was also during this period that high-level programming languages truly evolved. Fortran, short for formula translation, was specifically created for scientific and engineering calculations by a team led by John Backus at IBM in the 1950s. ALGOL, short for algorithmic language, emerged as a revolutionary language to describe algorithms in a structured way. It later influenced many modern programming languages. Additionally, the C language, developed in the early 1970s by Dennis Ritchie at Bell Labs, is celebrated as a third-generation high-level language because it combined structured programming features with close-to-hardware efficiency, bridging the gap between machine instructions and human-readable code. From 1971 onward, we see the dawn of the fourth generation characterized by the development of the microprocessor. The launch of the Intel 4004 chip in 1971 marked the beginning of personal computing. This era introduced user-friendly graphical interfaces and gave rise to laptops, desktops, and eventually tablets. Computers became accessible, powerful, and personal, transforming the way we work and play. Today, we stand at the threshold of the fifth generation. This era is defined by artificial intelligence, advanced data processing, and even the nascent field of quantum computing. Here, we encounter the concept of the qubit, the quantum bit. Unlike a classical bit that's either 0 or 1, a qubit can exist in a superposition of states, enabling quantum computers to process complex problems at speeds unattainable by conventional computers. This generation continues to evolve as researchers push the boundaries of what computers can do. As our digital world expanded, software milestones charted a new course. Netscape Navigator, launched in 1994 by Netscape Communications Corporation, founded by Mark Andreessen and Jim Clark, played a pivotal role in popularizing the internet. Moving forward, Oracle emerged as a giant in the software industry. Founded in 1977 by Larry Ellison, Bob Miner, and Ed Oates, Oracle revolutionized enterprise computing with its relational database management systems. These innovations reshaped business and communication, bridging hardware advancements with the digital network age. Not all computers are created equal. Let's clarify a few common classifications. Mainframe computers. These are massive and extremely powerful systems used by large organizations for bulk data processing and critical applications. Mini-computers, typically smaller than mainframes, these systems filled the gap in the 1960s and 70s by offering moderate computing capabilities for medium-sized businesses. Microcomputers, the family of personal computers, desktops, laptops, and even tablets that are designed for individual use. PDAs, or personal digital assistants. Once popular as handheld devices, PDAs managed contacts, calendars, and notes before smartphones took over the role. Understanding programming begins with language. At the lowest level, there's machine language composed of binary code, zeros and ones, that the CPU executes directly. Since machine code is hard to decipher, programmers use assembly language which employs mnemonic codes such as ADD or MOV that correspond to machine instructions. An assembler then translates this code into machine language. While assembly language is a step above raw binary, high-level languages like C dramatically improved programming efficiency and abstraction. Today we've traced the evolution of computers across 5 generations, from the vacuum tube marvels of ENIAC and UNIVAC, through transistor and IC innovations, to the microprocessor revolution and beyond, into the era of artificial intelligence and quantum computing. We've explored pivotal programming languages, the birth of the Internet's revolution with Netscape Navigator, and the establishment of Oracle's legacy in enterprise computing. We also clarified what distinguishes mainframes, mini-computers, microcomputers, and PDAs, and explained the basic differences between machine and assembly languages. This journey illustrates not only how far we've come, but also the fascinating innovations that continue to push the boundaries of technology. Computing history is a testament to human ingenuity. From the first bulky machines to today's cutting-edge quantum research, every step has paved the way for a smarter, more connected future. Thanks for watching. Subscribe for more deep dives into technology's evolution.